Hello, everyone, and welcome to my talk, The Mindset of Debugging. And I hope you've been enjoying the Ruby's comp so far. It's almost the end of the last day. We've almost made it through. Just a few more talks left. There we go. My name is Kyle D'Oliveira, and I'm a senior software engineer based out of Vancouver, BC, Canada. And I've been working with Ruby for over a decade now, and I think the language and the community are incredible. And I'm really happy to be here to be contributing back to the community as well. Let me get the slides to move forward. Maybe I'll just, there we go. I work at AHA. We help companies build what matters to them with our suite of products. We have an amazing team that's fully distributed by design, that's all over the world. And we have one of the best company cultures that I've ever been able to experience. And just like everyone else at this conference, we are hiring. Oh. And there was another talk yesterday, The Science and Magic of Debugging, that touched on some of the similar subject matters as well. And while there's a little bit of contact overlap, I think the talks are quite complementary. If you haven't seen that talk, you can dive deeper into debugging with that talk as well. So I'd like to begin with today's talk with a very short story about a competition between two lumberjacks. And while this is a talk about the mindset of debugging, there's still an important lesson here that I think we need to embrace when thinking about debugging or learning in general. I feel like I need to be certain. There we go. So we have two lumberjacks. We have Fred and we have John. There we go. Our first lumberjack, Fred, was a very hard worker, and he thought he could chop more wood than anyone else. So he challenges John to a competition. The rules of the competition are straightforward. Whoever produces the most wood at the end of the day would win. So the next morning, they began, both chopping away as fast as they could sustain. And after a while, John stops. Fred realizes there's no sound coming from his competitor's area, and he thought, aha, John must be tired already. There's no way he's going to be able to catch up to me. And soon enough, John starts chopping wood again, and the two competitors continue. But after a while, once again, Fred heard his competitor go quiet. This further motivated him. He could smell victory. He could easily maintain the pace he was going. And this pattern of John starting and stopping continued throughout the competition. And as the competition came to a close, Fred was as confident as ever in his victory. However, when it was all over and the amount of wood was chopped and counted, it turned out John had cut more wood than Fred. Astonished, Fred asked, "How could you have cut more wood than me? I heard you consistently stop working." "And it's very simple," John replied. "Every time I stopped while you were chopping away, I was sharpening my axe." And this is the idea of slowing down in order to speed up. And it comes up in many different areas, and it can be really powerful as a tool for learning. In the world of programming, we don't have literal axes. At least, I really hope we don't have literal axes. But our axes are our minds. And we sharpen our minds through intentional learning and focus. This talk is the mindset of debugging, and the core message around debugging is that it's a skill, and we should be intentionally sharpening that skill. And what comes to mind when you think about debugging? You may jump to tools like pry or bybug. You may think about websites like Stack Overflow. And these are tools. And tools can be very helpful and very valuable in the process. In fact, if you don't have access to the tools, things can be much harder to debug. But that is not the focus of today's talk. Debugging is a process. It's the process of detecting and removing current or potential errors in code. And it requires looking at all of the data in front of you, all of the accumulated knowledge you've built up, to come up with a theory of why something doesn't work the way you expect it, and then writing code to fix it. And there's no silver bullet to learning how to debug. There's no magic tip that will make you 10 times better at debugging if you just learn it. You need to first build a foundation of knowledge to be able to do it quickly, and that's something that takes a lot of effort and intentional practice. What you can do, though, is you can approach debugging with a particular mindset, one that gives you a framework to build on and can help increase the rate in which you're learning. The purpose of today's talk is to outline one possible such mindset, but to also get you thinking about the ways that you can approach debugging that best facilitates your growth. You could spend your effort and energy in a number of different places, so there is a good question of why should you put the effort into learning how to debug? Back in 2013, out of the Cambridge Judge Business School, a study was done to break down the software engineers' time that they surveyed. They found about 25% of the time was fixing bugs, about 25% of the time was making code work, 30% was writing code, 20% was designing code. And fixing bugs and making code work are both what we can consider debugging. And while this study was not specific to Ruby, it is still accurate from my experience. But just take a moment to think about that. 50% of your job is potentially spent debugging. That's wild. I have rarely seen training on how to debug. There are plenty of talks that exist and discussions on how to write good code and what are good patterns. But how often are we taught how to debug something? Sometimes we get introduced to a new tool, and there's new ways you can use the tool, but how often are you taught how to debug? Often learning debugging is just a side effect of you doing your day-to-day job, yet it is also the majority of how you spend your day. Debugging is also something that's said to be really difficult. Brian Kerningham said this: everyone knows that debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, how will you ever debug it? And in a way, this is encouraging people to be less clever when writing code so that it's easier to debug. But there's another message here. It kind of gives the impression that if you ever come across code that is really clever, you're not going to be able to debug it. It's impossible. Not to mention, when you're debugging, you're often facing external pressures that can intensify those feelings and can make hard things feel even harder. And it's also a common joke in the programming communities that if your tools are unavailable, you can't do your job. Stack Overflow is down. We're all going to die. But that's also not really true. You can still do your job. And there's also the joke that bugs just eventually become features. And hearing this over and over can reinforce developers, especially those early in their career, that not only is debugging difficult, but likely they're not going to be able to do it. They may as well just give up, find the easiest way forward, or just ignore the problem. And hypothetically, even if we were to deploy no bugs, because making code work, as we saw from the study earlier, is still a significant period of time, you're still going to need to learn how to debug. And honestly, it's not realistic to ever expect to deploy no bugs to production. So debugging is a skill we're always going to need to learn and always going to need to focus on. And debugging can be viewed as a series of experiments to determine what's wrong with the code. So we can pull a little from the scientific method. You've seen this come up a number of times throughout the conference. And conceptually, this can be simplified to just a few steps. You can figure out what your observations are. You can create a hypothesis that lines up with those observations. You create an experiment to validate or test your hypothesis. You analyze the data, and then you repeat. However, I think little effort is spent at the hypothesis stage, and this is one of the most important steps. This can inform you while debugging on what should you test next and help keep you focused. Without the hypothesis stage, debugging becomes a little bit of a guess and check game. I'm sure you've all had that experience where you just start removing pieces of code and hoping the bug goes away. And it's really easy to dismiss each of these steps as being obvious. But there is value in taking time to stop and think about each stage. You should be fighting that urge that says, well, this is obvious. I don't need to acknowledge it. Because fighting your assumptions is really important for debugging. And part of that value comes from a principle called active recall. And this isn't the next big thing out of Rails, but it's a principle of efficient learning that claims that we need to actively stimulate our memory during the learning process. And it's a very efficient tool of consolidating long-term memory. And there's a few different ways to practice active recall, but one such way is to just stop and ask yourself a question, and then dig into your past experiences to come up with an answer. And the important thing is, do not give up when it becomes tough. Instead, be curious. Talk about what you do know. Talk about what it could be. Ask for help. Take a step back. Go do something else. Come back with fresh eyes. But do not give up. One of the best ways to learn and grow is to just be a little bit outside of your comfort zone, and then your comfort zone expands. But this is a lot of theory, and I thought it would be interesting to go through an example. And very clearly, the example is made up, and it likely won't be related to the domain you work in, but the focus here isn't the example. The focus here is the process from start to finish. So let's pretend it's your first day of the job, and you get a bug report from a customer. And the customer says, I tried to update a contact's phone number. It said that it's saved, but the number wasn't updated. And they're worried that they're losing data somehow. Okay, what do we do from here? We can note some observations. If this is all we have, we can create a fact that says, yeah, we know that contact updates aren't working. Okay. Using that observations, we create a hypothesis. Maybe something that was deployed recently broke the contacts. How do we test this? Well, this seems like a straightforward test. Why don't we just try it locally? That seems like a good first step. So we spin up our server, and we enter in the contact's name and the phone numbers, and we save it, and that works. Okay, that's a little bit weird, but we can be a little bit curious. And we look into our local logs, and we can see what the entry path is. What did this hit? What code did it touch? Looks like it hit a contacts controller. And we can open that up, and we can see what that looks like. It looks pretty simple, but it looks like it delegates a lot of behavior off to another service. So you can continue to be curious, and you can dive into that service and see what might be going on. You can note some facts. It's a plain Ruby object. It holds some sort of reference to a contact. Maybe that's important. Does something in a transaction. It updates a name. Looks like it finds a phone number if it exists or builds a new one. And then at the very end, it updates it. Nothing seems to stand out as obviously broken with this code. So maybe check the tests. And the tests are up there. There's some sort of test that checks the name updates, that you can create a new phone number, that you can update a phone number. That all seems to be okay and seems to be working. So what can we conclude from our experiment? Well, we can kind of conclude that the typical contact update flow works for us. Well, now what do we do? Do we just give up? Do we say, works for me? Do we shrug? Do we say that the client that emailed us is probably lying or doesn't even know any better? None of those really help us get better at problem solving, and likely there is an underlying issue somewhere here. We should continue to brace this feeling of being uncomfortable with the unknown. How many times have you passed over a bug simply because you didn't know that area of the code? Sometimes I think that we need to have a baseline experience before we can even begin to debug code. But that's not true. Debugging is often one of the best ways to learn a code base. And when you're pushed just a little bit beyond your capabilities grow. So we can continue. We can update our observations, and maybe we can make that hard statement of saying, maybe I was wrong. Maybe the fact was not that contacts weren't updated, but maybe some contacts don't update. Okay, this changes things a little bit, and we can continue this path. We can create a new hypothesis. Well, if the path that I tried worked, maybe they didn't try that path. Okay, now we have a question. We can now go to our tools to figure out an experiment. Well, could we determine what path the customer took? We now have a question in mind. We can ask people, hey, how do I determine what the customer did? So maybe we do a little bit of forensics. We find the time that they submitted their issue. We open up like an APM that might have access to requests. Maybe this is a tool you have available. We could compare some time. We could look for requests roughly around the same time, and we could see what they were doing. And in this case, in this made-up example, looks like they did hit the contact endpoint to update things around the time that they reported it. So maybe we actually conclude that they did take the path that I took. Okay, well, that's a little bit weird, but we don't have to give up. We can continue going. We note that in our observations, we add a new fact. The user went through the expected path, and we create a new hypothesis. We have more information. Well, in that persistence service that I briefly showed, there's a conditional. Maybe they didn't pass the parameters correctly. So how do we test that? Again, we have a question. This can give us focus. We can look for tools. How do we determine what the parameters a user requests provided? Well, maybe your APM has a link to the request UUID, and you can go dig information out of the logs. That's a useful tool for debugging. And from the logs, you could see that there is a phone number being present. You'd also see the ID of the contact. We have a little bit of information here. So we can conclude that maybe the request did provide the expected parameters. We continue the cycle. Go back to your observations, add a new fact, and now what do? We make a new hypothesis. We keep going. We keep doing this process. And this process may seem redundant, specifically if you have a lot of experience and you can jump steps. But it's useful to just walk through it, especially if you are early in your career. So maybe a new hypothesis. Maybe the record isn't being saved. How do you determine this? Maybe it's a little bit harder to determine. It wouldn't be saved if there was an error. So we have a question. Let's figure out, was there an error? Now you can go back to your tools. You can look up your tools in Sentry, Datadog, Honeybadger, anything that you use for tracking errors, and maybe we find there's no errors. And that kind of makes sense, given that even from the logs, it was completed okay. So we still get some information here. We know that there are no errors to be found. We can add that to our observations. But this didn't really reject our hypothesis. And this is something we also need to be careful of. Sometimes we think that there are experiments that would show us one thing. But if we get data that we didn't expect, does it reject the hypothesis? And in this case, I don't think so. We need to keep going. What else could we determine if this record was being saved or not? Well, we create a new experiment. Maybe we go and check the database directly. And maybe you have the ability to check data on a production database. Maybe you don't. But this is a good opportunity, if you needed to potentially add tooling. If you had a tool like PG Hero that can run explains or analyze on your code base, you could theoretically write some custom SQL and analyze it and look at how many rows that came back and determine, hey, there actually is a row that exists in the database that matched these conditions. So you could conclude the database does contain this phone number. So we can add it to our observations. Oh, too much. There we go. We can add it to our observations, and we can start trying to create a new hypothesis. And if we go back to that persistence service, there's a find by here, which runs some SQL that looks like this. Select phone numbers from phone numbers, where a contact is some sort of number, limit 1. And if you eventually dig deep enough, maybe you find in the documentation of Postgres or your database that says something along the lines of, if you don't provide an order by to a statement, the order that it returns it is not guaranteed. So maybe there is a new hypothesis here. Maybe there's more than one phone number for a contact, and our assumptions about the system were wrong. How could we determine this? We could fall back to the database again. We could check something there. We could go back to a tool like PG Hero, write some queries, analyze them, and determine the number of rows. So we see that there are 2 rows here. So there are 2 phone numbers for this contact. And we can actually now explain something. We can say that, come on. There is no unique constraint on the phone numbers for contacts. So it is possible that one contact has more than one phone number, and because the service applies no order, the record it updates is non-deterministic. So this process gives us a nice, easy fix if we wanted to fix this hypothetical bug, where we just come into that service and we add an order by. Now this bug is fixed going forward. But there's some interesting things here. We had a hypothesis. We thought updating the context didn't work. And you learn how to find that part of your code. Where is the entry point? What does the code do? You learned a little bit about that code base. But you were wrong, and that's okay. There was a new hypothesis. Maybe they took a different path. And you have an opportunity to figure out a tooling that could help you answer this question. If tooling didn't exist, this is an opportunity to suggest it, add it, make everyone else better. But again, we figured out what path the user took, and we were wrong. Maybe the user didn't provide the correct parameters. Another question, we were able to leverage different tools, but again, we were wrong. Maybe the phone number wasn't saved. Nope, that wasn't it. Maybe there were 2 phone numbers. And finally, on the 5th attempt, you got it. And that's okay. We were wrong many times on this journey, but every time that we had something was wrong, we learned a little bit more, and we probably learned a little bit about the system that we're dealing with. And going through this process, maybe you have other questions. How do we fix the value that's already in the database? How do we consolidate this? This breaks our assumptions. Maybe we need to merge them somehow. Maybe we could think about how this appears somewhere else. Maybe there are other associations that we have this has one association assumption that's wrong. Could we ever prevent this from happening again? That's a good question to ask. In this case, you could add a unique constraint to the database, and then it won't happen again. But these are all interesting questions that could pop up along your journey and are important to note. We can approach debugging methodically like this, and it can become a tool to help strengthen us further. It can help you learn the code domain you're working with and create a mental model of the system you're working with. It can help highlight tools that are super useful or tools that are lacking. And then you can help build those tools to improve everyone's ability to debug. And it also helps you build a foundation that can make debugging other problems easier in the future. Debugging isn't magic. Debugging is just routinely practicing until you get really good at the skill. Personally, I recommend taking 30 to 60 minutes of your day, a few times per week, to stop what you're working on, stop working on your feature, but focus intentionally on a debugging task. This could be opening up whatever error tracking software you might use to find errors and just fix them, or maybe find more information about them so they could be fixed in the future. Maybe it's from the tests that occasionally fail on your master branch. We saw from the keynote today, you don't want to get into the situation where half your tests fail on your run. You could spend some time to fix it and learn. We aren't built to debug all day, every day, but we can focus on short intentional bursts to see what we can get done. And it's one of the easiest ways to train yourself, and it's one of the easiest ways to train others. And almost all the time, there is a measurable improvement that you can make on the business. If you're fixing errors, those are errors that your customers are not running into anymore. It's a win-win. Remember the story earlier about sharpening your axe and honing your skills. This is one way to do it. This is one way you can hone your skills for debugging and sharpen your mind. And it's not going to come from free. It's going to happen little by little through conscious effort. However, the more intentional this effort you put in, the faster this process will get. And if you feel like your axe is currently very sharp and you don't need to do this, you could spend some time to push to help others sharpen their axes, sharpen their minds. If you know how to debug super well, how can you push yourself to teach others? This helps you change from being an additive force within your company, where you contribute yourself, to being a multiplicative force, where you make everybody around you better. Thanks for listening to my talk. I will answer any question that pops up on the Discord channel, probably after this talk, and we have about 5 minutes for any questions, if anyone has any.
What are some of the lesser-known debugging tools you really like to use? Like, we're probably all familiar with Pry, Bybug, New Relic. Any other ones stand out to you?
I mean, for most of the debugging that I do, it's mostly just knowing how to answer questions. So knowing where are your entry points. Is that a controller? Is that a job? Is that a rake task? Those will really help. Personally, I go really low level with tools. Like put statements are great. A debugger where you can just inspect variables is great. Being able to use, there's a gem called method source, where you can use Ruby to display the Ruby methods. That's super useful in line when you're in a debugger, and helps you step through code that way. Most of the time, I don't think we need really complicated tools. We just need to know what tool can serve to answer which question. Okay, well, thank you for coming. You got a couple more talks left, and you're almost through the day. Take care, everyone.